A very good morning to you all, everyone. I hope you had a good rest and are ready for today's sessions. Before we begin with the session, please allow me to quickly go through some housekeeping announcements. Kindly switch on your phone to silent mode during the sessions. Please ensure that you proceed for the sessions on time. We encourage you to wear a mask in case if you need one. Please feel free to get one from the registration counter. We have prepared certificates of attendance for everyone. Please get those from the registration counter during coffee breaks or lunch. We will start our sessions for today with keynote address by Dr. Aditi Mukherjee from the International Water Management Institute, Sri Lanka. The moderator for this session is Professor Daniel Carte from the United Nations University, Flores, Germany. May I please invite Professor Carte to take over the stage.
Thank you and good morning, everyone. Welcome to the third day of the Water Security and Climate Change Conference. And it is my honor this morning to announce the keynote speaker, Dr. Aditi Mukherjee, who will be speaking on the role of water in climate change negotiations, reporting on her experiences from the recent IPCC assessments. Aditi Mukherjee is a human geographer by background and received her doctoral degree at the University of Cambridge in the UK. She received her master's at JNU Delhi, India, and I'm even more happy to say that she did her undergrad education at Presidency College, Kolkata, where I also spent 1 year as a researcher, as a young student. Aditi Mukherjee is a member of the core writing team of the IPCC 6 assessment report and was the coordinating lead author of the water chapter of the Working Group 2 of IPCC that dealt with impacts, adaptation, and vulnerability. Aditi Mukherjee is the principal researcher at the International Water Management Institute in New Delhi and has published more than 60 peer-reviewed research papers, mostly on South Asia, but also covering, for example, the Nile Basin, Central Asia, while at the same time also taking the global perspective, for example, in her role at IPCC. So besides being more of a generalist working on water security under climate change, Dr. Mukherjee has also substantially contributed to research on Asia's groundwater boom and on climate change and adaptation to climate change in mountain regions, such as the Himalayas and the Hindu Kush, including the impact that this climate change has on local livelihoods. As this is the Water Security and Climate Change Conference, I think it is perfect to have as the last keynote of the conference Dr. Aditi Mukherjee speaking on the role of water in climate negotiations. Dr. Mukherjee, the floor is yours.
Thank you, Daniel. You kind of made me sound cooler than I actually am. So thank you for a really nice introduction. Good morning, everyone. My name is Dr. Aditi Mukherjee, and today I'm going to talk about the results of the IPCC assessment that I was one of the coordinating lead authors, and I have several of our chapter colleagues in this room. We have Dr. Vishnu Pandey, who was a chapter scientist, and we have also two lead authors, Dr. Arfan and Dr. Elena Lopez Gunn, yeah, Arfan is here and I don't see Elena. So it was a joint effort. This IPCC chapter, we were 2 coordinating lead authors, 10 lead authors. We had 2 chapter scientists and over 50 or 60 contributing authors. So it's a collective work that I will be presenting on behalf of everyone. And I am pretty sure that we have used in this assessment papers and reports, primary work done by almost all of you in this room, because as you know, IPCC does not do primary work. Our job is the job of the authors is to synthesize whatever publicly available research is available on the topic. I will also briefly talk about the climate negotiation bits, given that this time, for the first time in the history of COP ever, to the best of my understanding, water made it to the cover document. This was the 27th COP that finished in Sharm el-Sheikh, and water has never been really mentioned in any of those COP documents, even though we know, most of us, and I feel I'm talking to a room of converted. We all know that majority of the people, particularly in the global south, face the impacts of climate change through water impacts, and yet water had never made it to those negotiations. Now also, it's not as if water has a huge role in the negotiations per se, but one tiny step is that water is now mentioned in at least the cover text of the document. With that, so as I said, climate crisis is also a water crisis, yet it is largely neglected in climate change negotiations. But as I said, we had some positive change this time in the COP27 with water being mentioned. So I want to divide my presentation into 5 parts, and this draws largely from our chapter, but also from the other working group chapters of the IPCC. My storyline is something like that. Why do I say that climate crisis is also water crisis? The first is climate change has led to changes in all components of the water cycle. Almost no component of the water cycle remains unchanged. I mean, we can see fingerprints of climate change on almost all the components. It has resulted in impacts, and most of those impacts are negative. There are some positive impacts in temperate parts, but majority of those impacts are negative in almost all sectors of the economy and society. And largely those negative impacts are being felt in the agriculture sector, which is hugely climate exposed. The third point that I would like to make to this August audience is that majority of those impacts are actually felt by people in the global south who are in a climate exposed occupations like agriculture. But global south, the impacts are also, not only the impacts are because of their location in, say, tropics, subtropics, humid, dry tropics, etc., but the disproportionate impacts on the global south is also an artifact of the vulnerability, which also traces to another process that has today led to climate change, and those include things like colonization and historic kind of deprivations that have happened in these global south countries. So IPCC this time actually also identifies colonialism as one of those root causes of climate change. Then my fourth point is around almost, not only is the impacts being felt through water, so water is kind of, the problem, but water is also a part of the solution. We are finding from a global meta review that almost 60% of all adaptation, documented adaptation, we have to remember that even documented adaptation are a very small subset of all the adaptation that is happening, because not all adaptation gets documented, right? I mean, not every community is documenting everything. But what we are finding is 60% of all adaptations are in response to water-related hazards. And more importantly, many of those adaptations also use water. Irrigation is an example of an adaptation. So is things like rainwater harvesting, better management of water resource, etc. And my final point will be around mitigation, which is less discussed in the context of water. Water is often discussed more in the context of adaptation. But it's also important that if this decade is to be the decade of mitigation, which it must, then water also has a big role to play in mitigation. So with that, and please let me know if when I'm over my time limit. So the first is, this is a diagram from our chapter. All components of the water cycle have been affected. These include heavy precipitation, droughts, floods, melting of cryosphere as some examples. So this is a figure from the IPCC Working Group 1 summary for policymakers, and each of those hexagons are a stylized map of the world, and each hexagon shows a particular region. So everything that you can see in green, those are the regions which has already seen changes in heavy precipitation since the 1950s. And you can see that almost, those 19 of those regions, and these have seen not only heavy precipitation, but these are also, there is a high degree of confidence. These are statistically highly significant. And much of Southeast Asia, where we are now, South Asia from where I am, and you can see much of Asia has seen increases in heavy precipitation. Similarly, when we look at the water cycle has been affected by droughts, we can again see that of the regions, 12 regions have seen increases in droughts, and other regions we are seeing low agreement in the type of change. Example, South Asia, Southeast Asia, and then also parts of Africa. So while there is no agreement whether droughts have increased or not, but I think the science is not yet agreed, but there are lots of those parts, particularly in Africa, where we see an increase in droughts. Then we also see that all components of the water cycle have been affected. This is around melting of cryosphere. This has been covered by, this is a figure from our chapter where we are seeing that glaciers are melting at unprecedented rates in all regions, including the Hindu Kush Himalayas, affecting cultures and ways of life of people. In this figure, we have actually tried to also relate the changes in cryosphere to the lives of the indigenous people, because many of these cryosphere dependent places are where the indigenous populations live. And so these are some are from the Hindu Kush Himalayas, which as we know is the source of 10 Himalayan rivers. And this is a slide I'm using from Isimode, where I used to work earlier. So if you look, this is a picture of the northern side of the Mount Everest, I believe, from an expedition in 1921. And if you keep your eyes fixed on any point of the slide, and if we do the change, you can see that the glacier in front has actually melted by 2009, leaving behind a glacial lake, and glacial lake outburst floods are one of those risks that are being increasingly faced for hydropower projects. For example, we are reading of these lakes bursting and damaging hydropower plants, apart from all other inputs, all other impacts. So what do these changes mean for the region's water resources? Well, I'll come to that in a minute. But what we are seeing that not only all the graphs previously that I showed, and here I want to make one more point. The difference between AR5 assessment and AR6, if you go through them, you will find that in the previous cycle of the assessment, every chapter had a longer content on the projected impacts, while it didn't really have so much of content on the current impacts. But in AR6, actually, we find that there is so much of now evidence and clarity and documentation on the current impacts that our observed impact sections are just as long as the projected risk section. And I think that's actually pretty scary, because we are actually seeing most of those impacts. And now, if we look at the future impacts, it's pretty clear that all those impacts intensify at higher levels of global warming, from 1.5 all the way up to 4 degrees. And this is on top of it, and I know this is again an audience which knows it very well. This is on top of the fact that already 4 billion, half of the humanity, faces severe water scarcity for at least 1 month per year due to climatic and non-climatic factors. The current water scarcity is also because of a lot of other vulnerability, access issues, economic conditions, governance issues. So climate change is actually coming and affecting water sector on top of the vulnerabilities that are already there. So the second point that I come to is that all sectors of the economy and society, especially in the global south, are feeling the negative impact. So this is a graph from our chapter where we have assessed basically through hundreds and thousands of studies around, look at the impacts that climate change had on those. The top part is more on the physical parameters, which includes things like heavy precipitation, cryosphere, river runoff, etc., while the bottom part that I have circled are around the sectors: agriculture, energy, sanitation. So you can see that pretty much all the sectors had negative impacts. Just to give into some of these examples, agriculture, we are finding that 3/4 of global harvested land experienced drought-related agricultural losses between 1983 to 2009, with production losses of 9 to 10% due to weather extremes alone. Energy, between 1981 to 2000, we are finding that utilization rate of hydropower plants declined by 5.5% in drought years compared to normal years. In health, we are finding extreme events like floods are linked with increased incidence of water-related diseases like diarrhea. In urban, we found that 17% of cities have already experienced statistically significant increases in extreme precipitation. Part of it is also the urban heat island effect. And in freshwater ecosystems, we are finding that 35% of wetland area decline, with climate change being an important driver. Not the only driver, but important driver. Then coming back to the cryosphere bit, we are finding that impacts of these changing water cycle are being felt disproportionately by women, poor, farmers, and indigenous people. This is a map from our chapter where we kind of have smaller case studies for some of those locations where these cryosphere impacts have been felt by indigenous population who live in those cryosphere environments. Then those who are most vulnerable, so this is where the climate justice part comes in. Those who are most vulnerable have not contributed to carbon emissions, and global warming are the most facing the severe impact. So this is again a picture. We used to work in this particular village in Ladakh, and they depend on those glaciers that you can see far back. And this entire, you can see how dry everything is and how green and verdant the valley is. So they have very integrated traditional system of bringing water from those glaciers and irrigating. But now those glaciers are melting faster and their irrigation systems are getting completely decimated. And in these villages, elders will ask you, what can we do? And the reality is that there is so little that they can do, because it's not their actions that are melting those glaciers, right? And the results that we are finding is mass migration. They have to leave their traditional ways of life and move to cities and do all kinds of jobs that they does not necessarily go with their traditional ways of life. Now I come to the fourth point of mine. So this was more of a problem statement. Now what we are finding is we did a global meta review of around 1900 articles around adaptation, and we find that water is central to adaptation, with almost 60% of all adaptation is occurring in response to water-related hazards. This figure, I don't know how well you can see, on the rows are the 16 main types of adaptation that we have assessed. Includes things like improved cultivars and agronomic practices, changes in cropping pattern, crop systems, on-farm irrigation, so on and so forth. And then we are kind of seeing these adaptation in response to what? And in majority of the cases, we are seeing that these adaptations are in response to either drought, precipitation variability. Also heat-related ones are becoming increasingly important, and other things like inland flooding and etc. So basically, people are also, farmers and others are also adapting to climate change because they're feeling those water-related impacts. We are finding that these water-related adaptation is happening in all regions, and more so in Asia and Africa, obviously, because that's where much of the dependence on agriculture is there. And the green ones are basically, again, the sectoral ones, and we are seeing that majority of those adaptation case studies we are finding are from these regions. So where there is like blank doesn't mean that adaptation isn't happening. It simply means that perhaps the documents were not covered in our assessment for various reasons. They may not be available in an English form, or they are not documented and published in peer-reviewed literature. We are also finding that water-related adaptation have many benefits, but what is, I think, a major highlight from the AR6 assessment is that we do not know if adaptation reduces climate risk. And I think that's a pretty a pretty important thing to say, because we know a lot of investments are happening in adaptation. We also know that adaptation has many benefits, for example, in terms of livelihoods, in terms of impacts, maybe in terms of water saving, maybe in terms of environmental flows. But are they actually reducing climate risks? You know, climate risk being reduction in hazard, vulnerability, and exposure. And that's where I think the literature is very silent. And this will be a major gap that I think we as a researcher have a moral obligation to fulfill for the next AR7 cycle overall, to actually use those analytical lenses to see how effective adaptation is in reducing climate risk. We then also looked at the future effectiveness of adaptation. It is one thing to say that we do not know if adaptation is being effective. Maybe it is beneficial, but whether it reduces climate risk is an open question. But even more importantly, we know that we are on a trajectory to touch 1.5 degree very soon, a decade or so from now, and that's very soon. And what happens to the current adaptation at those higher levels of global warming? What we are finding is at different, and usually the adaptation literature has been very temperature agnostic. Much of the work we do in adaptation doesn't really relate it with different temperature goals. Mitigation is very temperature conscious, because mitigation is all about temperature. But in adaptation, we do not usually look at temperatures and future adaptation. There's a much smaller body of work, around maybe we could assess around 40 papers compared to 1,000, 2,000 papers on current adaptation. So what we are finding here is that as the, this figure, as you kind of basically what to see is that the blue parts of it, blue part is the effectiveness, how effective a particular adaptation remains at higher levels, and the red part is how the residual risk increase, and you will see that the red parts increase. Maybe this figure is a better one to show you. We have here juxtaposed both the current and the future adaptation, and when you see those really red and orange, blobs, that basically says that those adaptation, lot of residual risks are left even after adaptation. So for some of these adaptations, say improved cultivars, they do not seem to work beyond 1.5 or 2 degrees. I mean, the drought tolerant seeds that we may be investing in now will not work beyond a certain level of warming. So this actually says that adaptation by itself is not enough unless we are also mitigating the impacts of climate change. Basically, we have to do emission reductions now. Otherwise, even adaptation will not be very successful. So so that's something. Now I come to the final part of my one, because our report clearly shows that there are limits to adaptation. Endless adaptation is a myth. The world cannot keep on adapting. Farmers cannot keep on adapting while we continue to emit greenhouse gases continuously into the atmosphere. So therefore, it's pretty clear, irrespective of the actions that are happening, the science is pretty clear that this is the decade where we have to do a lot of the mitigation if we want to give us any standing chance of being true to the Paris Agreement. So, however, most of these mitigation measures, including carbon dioxide removal approaches and technologies, can have large trade-offs with water and food security. For example, some of these like bioenergy crops, and I'm sure many of you work on bioenergy crops, and we know that replacing large areas from food crops, transferring it to bioenergy crops can have implications on food security, on crop prices, etc., etc. Similar is the case of afforestation and reforestation. Again, it is an important tool of mitigation, but if done in inappropriate locations or inappropriate species, then it can lead to trade-offs between land biodiversity and water resources. So I will stop here and just summarize. So first of all, to summarize, climate change is experienced first and foremost through changes in water regimes, example, extreme precipitation, rainfall, etc. Since the most vulnerable feel climate impacts through water, water also becomes the vehicle through which climate injustice propagates. Water is a part of the problem, but also a part of the solution. Many of the adaptation measures that we see are being used everywhere involves water. Example, irrigation, soil moisture conservation, rainwater harvesting. And mitigation is the need of the hour, but if not well planned, some mitigation measures can make local water and food security worse through high water footprint. So water needs a seat at the mitigation table. So when the discussion, so that's why I thought it was important that water was mentioned in the cover document of the Sharm el-Sheikh work plan this time. Thank you so much, and over to you, Daniel.
So thank you very much for this excellent presentation, for highlighting that water is on the one hand a problem when we look at the impacts of climate change, but on the other hand also the solution when looking at climate change adaptation. That water is also relevant from the mitigation point of view, so that in the end we do not need to reduce only our climate footprint, but also our water footprint. Thank you for clearly stating that in the 6th assessment report you have looked not only at the long-term future impacts, but also the already observed impacts. And the case studies that you have presented, for example, looking at farmers in the high mountain valleys of Ladakh, have clearly shown that climate change and its impact on water cycles already have a strong impact on the life of some groups of people, especially the most vulnerable groups on this planet. But I'm sure that in the future, climate change and the impacts that it has on water will be transforming all our lives, and that we will need to do our best to adapt and mitigate climate change at the same time. Now, it's my pleasure to accept a few questions to Dr. Mukherjee, which I'm sure there are.
Thank you, Aditi. It's wonderful listening to you. And I'm glad that you mentioned climate crisis is a water crisis. So in one of your slides, you presented glacier retreat and especially the impact at Ladakh region. So my question is, because that validates whatever the model says, because you present it from the perspectives of community. So are the glaciers, because we relate glacier melt with a stream flow, and we do have a very strong relationship that there will be increase in flow during the glacier melt, and there is a turning point, and then we start having decreased stream flow. So with your presentation from the community or from this, the field work, that we are already in the declining stage, can you validate that based on your observation from the Ladakh?
I think we are not in many of the Himalayan rivers, but the declining stage is already reached in some of the river basins in the Andes. The Himalayas, I think the peak flow are expected around 2040s to 2050s.
But they are saying that they have observed a reduced flow, right?
For them, it's really the timing when the flows are coming in. So it's an early melting of the glaciers. By then, the fields are not yet ready. The fields are still, so for this particular community, the issue has not been so much about the volume, but the glacier melt is now coming before the fields have actually thawed properly for preparation for agriculture.
Okay, thank you. So it's the timing of the
Yes,
flow.
yes. So
Okay,
far
thank
it's
you.
the timing.
Okay, thank you.
But the peak flow will certainly happen, and the declining flow will also happen. Yeah.
I think it was a brilliant presentation. Congratulations. The key message that I could take from this presentation is that many of those adaptation measures, which you clearly said, may not really reduce climate risk. And many of those adaptation measures or many of the mitigation measures might have serious impacts on water. I think especially afforestation, large-scale afforestation in some of these semi-arid and arid regions can have serious impacts on river flows. I think they are very good messages. I have a couple of small clarifications. One on this in one of the maps you showed this how the precipitation is going to increase in South Asia. But when it comes to agricultural droughts, it doesn't show anything. It's not very clear about this uncertainty. I really wonder if countries like India, and you know it very well, if you get a lot of, there is increase in rainfall, and we know that we have got about 4,500 large dams in our country. Large dams, of course, one can always contest what these large dams mean. But then increase in rainfall can lead to increase in runoff, and it can also lead to increase in groundwater recharge. And we have millions of wells in our country. So it can definitely increase the agriculture production. That is what is really seen now. A lot of agriculture production growth is driven by increase in rainfall in many areas. So why is it that not showing any reduction in drought? We are always talking about increase in drought. What about the reduction in drought? Maybe that's also one point where you can look at. Thank you so much.
Yeah. Thank you, Dinesh. I think a lot of what is happening is around extreme precipitation, which does not necessarily lead to more recharge. Some of it will go to also runoff. So the entire relationship between runoff and recharge, between extreme precipitation and groundwater recharge, and I'm sure there are people in this room who know more about the relationship between groundwater recharge and precipitation than I do. But the relationship is not really linear. It's not necessary that, you know, what may happen. So the projection for India is, for South Asia is overall, there would be either increase in total precipitation or the total precipitation will remain the same. What will happen is that there would be those same amount of precipitation or increased precipitation will come in these series of very extreme heavy precipitation, coupled with a long period stretches of, you know, gap between two rainfall events. So what's happening is that then you are kind of seeing those kind of periodic short term. So for example, I do a lot of work in eastern India, in Bangladesh, and these are the places where the monsoon paddy, the almond paddy as it's called, never traditionally needed irrigation. Rain-fed irrigation, it was all rain-fed crop traditionally, but over the last 10, 15, 20 years, farmers are increasingly using irrigation, mostly because of very uncertain rainfall, in the sense that even if your total amount is the same, it's the timing that varies. I mean, this year is a classic example. There was almost no rain at all, you know, during the sowing period, and those without access to irrigation couldn't really sow their paddy. And then by the time paddy was sown, there was, like, you know, rainfall in October. So I think it's not only the total volume, but it's also how that rain falls. So I think that's an important one. And
more rainfall, more runoff means we will have more storage. And of course, yes, what you're saying is right. In some places, increase in rainfall will not lead to increase in recharge because of hard rock aquifers. But there are many areas which are alluvial. So where increase in rainfall can definitely lead to more recharge. And we have millions of wells in the country, and you know it very well. So that's why I said we have many reservoirs. So the reservoirs will take care of this increase in runoff, should have. And that's what the data shows. That's why. So you can.
yeah, sure.
Thanks so much.
Yes.
So thank you very much for the questions and answers, and I see that there is, I think, 2 more people now raising their hands.
Okay, thank you, Aditi, for a wonderful presentation. This is Yadu Pokhrel from Michigan State University. My question is about groundwater. Groundwater remains a challenging part of the water cycle, you know, not only for future projections and so on, but you know, even for the historical part, modeling and so on, because we can't see it and there's not much data available. Yeah. And it also relates to some of the adaptations like irrigation, because a lot of irrigation comes from groundwater. So, my question is, what is the major progress that we have made from coming from AR5 to AR6 in terms of better understanding the groundwater aspect of the freshwater systems, and also in terms of future projections, and also probably you could shed light on what are the key challenges in terms of groundwater particularly. Thank you.
Right. So my understanding is that the major progress that we see is the new literature that has come up around this whole thing around induce recharge due to extreme precipitation. So we are finding that in some of those dry land areas, particularly in parts of Africa, but also in peninsular India, there are some of these studies that are showing that actually extreme precipitation has already led to higher recharge even. So I think that is, the groundwater perspective maybe is a little more positive in AR6 than it was in AR5. And I would encourage you to also, I'm sure you have read that groundwater section, and it was actually written by Professor Shams of UCL. So he was the contributing author for the groundwater part of the report. So please have a look, and that will kind of tell you the difference between AR5 and AR6. But most of it is around this induced recharge due to extreme precipitation. Yeah, thank you.
Yeah. Thank you very much for the great presentation. Lars Ribbe, Technical University in Cologne, Germany. You mentioned that there is a need to really document and assess adaptation strategies, and I fully agree to that. When we are in the field, when we have projects, we often see great examples, but it's not the classical scientific activity. It's nothing you would publish in journals. It's even not often funded, to do this job. And universities could do it, but I think there would be a need for a kind of coordination. There would be a place also to send it to, or to, let's say, to document it, to make it available, and also to have perhaps better measures to assess it also region-wise, perhaps climate zone-wise, ecozone-wise, or whatever. So do you see anything like that emerging? Is there a kind of initiative of a UN institution or a kind of network that would be, I think, very helpful to also contribute to, to the assessment report 7 you said, but actually to the whole community to improve adaptation and future investments? That is actually the question behind it.
Yeah. That's a great question actually, and I do think lots get written on adaptation, particularly by the social science community, and there are a lot of journals that are quite, would be very happy to publish adaptation-related work. I mean, there are too many to recount, but on the top of my head are things like Climate and Development. That's a journal that focuses almost exclusively on, on lot of adaptation-related. So I personally, I mean, of course, a lot of adaptation happens, not all of it is documented, but the issue is that even of the ones that are documented, they're not often documented in a way that is a causal, you can link the adaptation action causally to the adaptation outcome. And that requires a particular kind of scientific framing which may be missing. So I think we have to think of a scientific framing that kind of can link an action to whether it's reducing risk or not. And there is a huge interest by the international community. I mean, this time at the COP27, there was an entire whole lot of discussion around global goals on adaptation. The UNFCCC and the countries are very keen to have those global goals on adaptation, like we have the mitigation work program. We have a mitigation goal, right? We don't have an adaptation goal. So within that discussions, there was this demand kind of for adaptation metrics. So I think there is a demand from the UN coming, from the, the international negotiators coming, and it's now up to us researchers to see how we respond to that demand. So I can actually say that there would be no dearth of journals to publish those papers, but the issue is that majority of the papers are case studies which have its own value, but they do not necessarily do that causal link. So maybe that's where we need to work. The other gap is, of course, how do we, not every adaptation, if you look into future adaptation, you have to then link it with the global climate models, and not all adaptation. How do you kind of put migration in a global climate model? So those kind of methodological issues is what I think we need to discuss as a global community. Yeah, I hope that answers your question. Yeah, thank you. Thanks.
So once again, thank you very much for this excellent presentation, Dr. Mukherjee, and for answering all the many questions that we had in the audience. I think there's even far more questions that people might have and that we can still ask in the coffee break. There is a last question from my side. When we look at this Water Security and Climate Change Conference and its outcomes, what do you think can we do to ensure that this conference has a real impact and not just make it one of hundreds and probably even thousands of conferences around this topic taking place worldwide this year? What can we do to really have an impact of this conference?
That's a big question. I'm sure all of us have our ideas, but again, because I just recently returned from COP and I know that they're also doing something called a global stocktake exercise, and they are very keen to get inputs into that global stocktake on the status of adaptation and mitigation. So I wonder if, you know, if the conference proceedings can feed into that process. Yeah. Thank you.
Thank you very much.
Thank you, Professor Karte and Dr. Aditi Mukherjee, for the enthralling session. I would now like to request Professor Karte to please deliver a souvenir to Dr. Mukherjee.
Thank you so much.
Thank you. We'll chat more. Thank you so much.
We have now concluded the first plenary session for today, and now we will have a short break, after which we will have series of parallel sessions which you can see on the screen. You can also refer to your program booklet in the registration kits. We also have displayed the program on the TV screens outside the room. Let's reconvene in this room at 3:15 p.m. for next plenary session. Thank you.